Hello, this is LORELEI MUCCI, and I'm really happy to be back with all of you again. Today I'm going to be discussing some of the questions related to critique of the literature from week 8. The paper that these questions are based on, it was the paper on looking at the study of pre-diagnostic selenium level in toenails and the risk of advanced prostate cancer. I had put together 4 questions related to the study design and interpretation of the study. I was pleased to see so many of you had posted your thoughts and responses to the 4 questions. And today I'm going to be going through some of the answers that I think are some ways in which you can think about these questions. So the first question that I asked regarding this paper is, why did the authors conduct a nested case control study instead of a cohort study among the 33,737 cohort members? So if you remember, this paper is based on a cohort study of male health professionals from the U.S. In the larger cohort, and this is called the Health Professionals Follow-up Study, or the HPFS. In this study, there were actually more than 51,000 men who initially enrolled in the study in 1986. And then in 1987, these men were asked to provide toenail clippings. And of the 51,000 men, more than 33,000 returned toenail clippings. And so we can call this the study base for our study. So the main reason that the authors decided to do a nested case control study rather than looking at selenium levels in all of the cohort members really is about efficiency. As you can imagine, it would be quite expensive. It could take a very long time, a lot of resources, if you were to measure the selenium levels in the toenail clippings of all 33,000 individuals. And so the authors undertook a case control study nested within the study base of 33,000 participants in order to get a valid estimate of the association between selenium levels and the risk of advanced prostate cancer. So really it's more of an efficiency approach. Especially for biomarker studies, if you do a case control study nested within a cohort, as the authors did, you can get a valid and efficient estimate of the association as if you had done a cohort study. So now I'm going to move into question number 2. Question number 2 was, in this design, the researchers identified a case of advanced prostate cancer, and then they sampled a control from the study base at risk. And the question that I asked was, if participant 1 was diagnosed with advanced prostate cancer, in parentheses, a case, in 1990, and participant 2 was diagnosed in 1993, the question that I'm asking is, should we let participant 2 be a potential control for number 1 or not? Should he be excluded? Now, this is a little bit tricky, and often when students are just learning about epidemiology, you might feel that it would be better to exclude participant 2 as a potential control for participant 1 because the person ultimately developed prostate cancer. However, in this specific design, and if you think about it from a cohort study, let's think about a cohort study first. So in a cohort study, you follow men or individuals from a certain time start of follow-up, and then certain people develop cancer. And when that person develops cancer, you look in a time survival analysis, all the people who are still at risk of getting the disease, part of the study base for that case. So if you think about it, this type of sampling that we've done, which we call risk set sampling, in this study, participant 2 would be eligible to be a control for the case who occurred in 1990. So although he developed prostate cancer in the future, he can be a control all the way up to the time point by which he develops cancer himself. Now, after he develops prostate cancer in 1993, he no longer would be eligible to be a control for any case in the future. So that question is a little bit challenging, but I saw that several of you had correctly answered that participant 2 would be eligible to be a control for participant 1. Question number 3 referred to the exposure. And for this study, the exposure was the level of selenium that was measured in the toenails. And I asked 3 different questions related to this. The first is, what is the window of exposure for the selenium levels? And what I mean by that was, what was the time frame that this measure of selenium referred to? We can often think about, especially with cancer, that you can have exposures that occur very early in life, those that occur midlife, later in life. What is the window of exposure and how is it related to the case? The second related question was, what are some of the potential limitations or biases you might think about around the measurement of this exposure? And then the third part of the question was, if there is bias, how might this bias influence the relative risk? In this case, the odds ratio was a measure of the relative risk in this particular study. So let's talk about the first question. So the toenails were all collected from the members in 1987. And in the discussion section of this paper, the authors refer to previous work by Longnecker and colleagues that said, what is the range of exposure that a toenail clipping might refer to? And so actually it's quite interesting. Toenails, if you think about it, you're getting the tip of the toenail. And so it would have taken all that time for the toenail to grow out. And so the selenium that's being measured really is a long-term average intake of selenium levels that reflect intake over about 26 weeks to 52 weeks. And this paper also, because selenium it really needs to be measured as a biological marker rather than asking people how much selenium they get in their diet, because as you may have seen from the article, the amount of selenium that occurs in food really changes quite a lot depending on where the food is grown. And so it's in order to study selenium, one really needs to measure the biological marker or biomarker of selenium, either in toenails or in blood. So we're talking about a measure of 26 to 52 weeks. So remember, this is a cohort study, so the selenium was measured in the toenails before any of the men developed prostate cancer. And then the men were followed prospectively, and the cases were diagnosed between 1998 and 19, sorry, please replace this, 1989 to 1994. So the window of exposure, if you're thinking about that, is 3 years to 7 years before the diagnosis of cancer. So since the average age of these participants at the time of the toenail collection was 63, we're really thinking about intake of selenium between sort of in more later adult life. So that's the window of exposure. So what are some of the potential limitations or biases? As I had mentioned, a biomarker in this case for measuring selenium is really important because it's quite challenging to just ask somebody to report how much food they take. You're not going to get an accurate amount of selenium they're getting from their diet. But there are some potential limitations. Even with a biological marker, you want to make sure that your assay is both reproducible and valid. And reproducible means that if you measure the marker in the same specimen over and over again, you're going to get the same answer. And validity refers to that the marker that you're measuring is an accurate measure of the level of selenium. And so ultimately, we probably don't really know what the truth is. So often we take as a first measure of, how well is an assay doing to measure a marker, looking at reproducibility. And so there is some information here on reproducibility, and the people can look at this with the interclass correlation coefficients or coefficients of variation. So both of those give some measure of how reproducible the assay is. And the selenium levels are quite high. The coefficients of variation were quite low. So that means it's very reproducible. And then also the second part, if we're thinking that this measure of toenail selenium is a measure of long-term status, we might want to know on the same individual if you had toenails at time one and then some time later, say in this case 6 years later, and you wanted to measure selenium, you want to ask the question, how correlated are those two measures? And in this case, they actually had data from another study, the Nurses' Health Study, and what they found was a correlation coefficient of 0.48 between those two specimens. And although a perfect correlation would be 1 and a value of 1, and having no correlation would be a value of 0, 0.48 is a moderate correlation. And actually, the authors state that this level of correlation is similar to what is seen with measures such as blood pressure, cholesterol, or glucose levels when you take things over time. And yet, these are still strong predictors of disease. So these are some of the potential limitations and biases that you could think of. Now, the final question is, how might this influence the odds ratio that we've measured for the study? And so what we think, and what I think is true in this case, is what you'd be concerned about. There could be measurement error of selenium, which is either random or non-random. And if it's random, that means that the amount of measurement error of selenium is similar for the advanced prostate cancer cases as it is for the controls. In this case, the lab was blinded to whether a specific sample was a case or control. That's really important when you're doing biomarker studies. You want to keep the laboratory blinded to the information on case control status. So in this case, if there is misclassification of selenium levels, it is likely to be non-differential. And then, therefore, any estimate of the odds ratio would be biased towards 1. So if anything, if there is measurement error, then the true estimate is going to be even a lower risk than what was seen in this study. So now the final question, question number 4. In this slide here, it's a table describing 3 different studies. The first is the first randomized trial that was published. This was the Larry Clark trial, and this was the basis for which both this current epidemiological study was undertaken, as well as a much larger randomized study called the SELECT trial. So the Larry Clark trial, if you remember, involved 974 men. They all had non-melanoma skin cancer. And the actual question that the Clark trial was trying to address was whether men who were randomized to selenium would have a lower risk of skin cancer recurrence compared to the men who were randomized to placebo. But what was interesting was in this trial, there was no effect on skin cancer, yet the researchers saw a significant reduction in risk of prostate cancer. So the relative risk was 0.4, and this infers a 60% lower risk of prostate cancer for men randomized to selenium versus placebo. So a relatively small trial. The men were followed for about 7 years, but the finding was so strong that it spurred a number of epidemiological studies to be undertaken, and then ultimately this larger randomized trial of SELECT. And so you've read a lot about this EPI study here. I'm going to talk a little bit about the SELECT trial. So that's the column on the right here. So in this trial, there were 35,000 healthy men at the start of the study. So they were all free of cancer at the start of study. The men were randomized in what was called a 2-by-2 design. So they were randomized either to get selenium alone, vitamin E alone, both selenium and vitamin E together, or a placebo for both supplements. The men were only followed for 5 years, and this is an important point, actually. They saw actually no association between selenium and risk of prostate cancer, so that the men who were the relative risk for prostate cancer among men randomized to selenium versus placebo was 1.04. So, if we go to the actual question, the question that I asked is, well, why do you think the results from the SELECT trial differed from what we saw in this epidemiological study? And actually, several epidemiological studies had seen findings similar to this current study, which was that men who had the highest levels of selenium had lower risk of advanced prostate cancer. So there were several epidemiological studies seeing the same association. And so the question I asked was, what are some of the plausible explanations for the differences? And I said to think about confounding bias as well as the actual measurements of the of exposure and outcome. Well, in observational studies, we are always concerned about potential confounding. And in confounding here, we might think, even though we see this inverse association for selenium and advanced prostate cancer, maybe it's not selenium per se, maybe it's another factor in the diet that's strongly associated with selenium levels. Maybe it's something like how much PSA screening the men are getting is different among men with high and low selenium. Maybe it's another factor. The authors tried to address this by examining a number of confounders and adjusting for those in their statistical models. And adjusting for these confounders, actually, if you look at the results from Table 3 in the study, even adjusting for, so in the study they adjusted for age, smoking, follow-up time, they adjusted for a number of different dietary factors, family history of prostate cancer, body mass index, vasectomy, and even adjusting for these factors, there was almost no change in the estimates of the relative risk compared to a model that just adjusted for the matching factors. So there could be residual confounding, but they adjusted for many of the known risk factors for advanced prostate cancer. So you might think perhaps confounding might only explain a small difference in between the observational studies and the trial. Now, there may be bias, of course, but actually, in this particular case, I think that probably the real difference is related to actually the way that the SELECT trial was undertaken versus the epidemiological study. So if we go back to this table here that looks at the differences in the study population, one of the key concerns that some people have is the relatively short follow-up of the SELECT trial. So the study was published in 2008 after only 5 years of follow-up in the study. Now, this is really important actually because of something in prostate cancer, which is PSA screening. So, the amount of prostate cancer that's diagnosed in the United States over time has changed dramatically because of PSA screening. And PSA screening is thought to lead to the overdiagnosis of many men with prostate cancer that really these cancers would never come to light clinically. And given the very short follow-up time, PSA screening actually introduces something called a lead time, where cancers are diagnosed about 7 to 10 years earlier than they would be in the absence of screening. And so one concern is that the men just were followed for such a short time, and because of so much PSA screening, the types of prostate cancer cases that were diagnosed in the SELECT trial are much smaller cancers, they're less aggressive cancers. In fact, the SELECT trial did not even report on advanced prostate cancer as an outcome. They looked at only at total prostate cancer, and therefore it may just be that there's the cancers in these two studies are really quite different. So that's one big issue between the SELECT trial and the epidemiological study. Some people have raised concern about the type of selenium that was used in the randomized trial. So it was the form of selenium was L-selenomethionine, and some researchers have suggested potentially that may not be the most active form of selenium. Other people suggest that's probably unlikely to be an explanation. And then finally, I think it's the window of exposure potentially also, that the the selenium levels that were measured in the toenails within the epidemiological study really might be a better long-term reflection of selenium over a man's lifetime, whereas the selenium, you know, was given to these men in a supplement form really late in adult life. So that could be an explanation. And then the final explanation might be that selenium may not benefit men who already have fairly high levels of selenium in their diet, and it really may just benefit men with the lowest levels of selenium. And that actually was seen in the Larry Clark trial, that when you stratified on the baseline levels of selenium that these men had, that the strongest effect of the supplementation was on the men who had very low levels of selenium to start with. So these are all some possible explanations. I think this is a question that's still of a lot of interest for researchers in prostate cancer, and so there'll be a lot more research on this topic. So I hope you have, I hope this discussion has been helpful with these 4 questions. I will be looking again on the website to see what your responses are, and I would be happy to talk further about these critique questions. Good luck with the rest of the course, and I've been happy to be a part of it. Thank you very much.